Have you ever wanted to automate the provisioning of services in the Oracle Cloud? Well, you might have heard of Terraform. This is the leading platform to deliver infrastructure as code and support many platforms, including the Oracle Cloud. While Terraform is advertised as infrastructure as code, do not be fooled. You can provision much more than infrastructure with it, like the Oracle Database Cloud Service, digital assistants, data science, content and experience service, and much more. So how does this Terraform work? Well, see it like preparing a meal. You write down in a structured form the recipes for your meal, including all the ingredients, like networking resources, load balancers, compute and database instances, and then hand it over to Terraform. It will then automatically create the environment for you as how you have described it in your recipes. If you've never worked with Terraform before, and maybe you're also new to the Oracle Cloud infrastructure, writing these recipes might be a daunting task, as you need to describe every single component in detail. But no worry, I will show you a method in this video that allows you to build complex Terraform recipes with just a single command. Terraform supports many platforms. It does this by a concept called providers. And Oracle has made a Terraform OCI provider module that you can find on the official Terraform website. This Terraform OCI provider has one special feature you do not find in most other provider modules. It's called resource discovery. Using this feature, you can build an environment manually once in OCI using the normal OCI web pages and then ask the Terraform OCI provider to discover these resources, meaning it will query everything you have created automatically and turn that into a Terraform recipe. It's like preparing a meal once and then automatically have the entire recipe and cooking instructions written out for you. Before you can use the Terraform OCI provider module, you need to have the OCI CLI configured. If you do not know how to do this, please check out the link in the description of this video. You can check if the OCI CLI is properly configured by running the command OCI OS NS get, which stands for OCI Object Storage Namespace Get. And this should return the name of your tenancy. Next, you need to download the Terraform OCI provider module. I'll put a link in the description of this video. Download the module that's suitable for your operating system. In my case, I'm using a Mac, so I'll download the module compiled for Darwin. And after you have downloaded it, you can unzip the file. For ease of use, I will copy the file to my USR local bin directory so it's automatically in my search path. You can now run the Terraform OCI provider module and you should see an info message with the version and a message that it's by default running in a plugin mode. You're now set to automatically create recipes for any environment that you have already created. Let me show you an example. I have a compartment here, and in this compartment I have already created a VCN with a subnet and all the associated resources like Internet Gateway and a properly configured security list. I have a web server as compute instance and an autonomous database service. I can run the Terraform OCI provider module with the export command. I need to specify my compartment name or ID and the path of where I want my recipe to be saved. The Terraform OCI provider will now query all resources in my specified compartment. It uses the credentials I've set up for the OCI CLI tool. When finished, the output directory will have a bunch of files that make up my Terraform recipe. Within OCI, there's a service that can now automatically deploy these recipes for you. It's called the Resource Manager service. Let me zip these files up and let's go to the Resource Manager service and see if we can deploy them. Here, I can create a stack and upload my recipe zip file. I will provide a name and a description for my stack, and we will click on Next. The Resource Manager will show all the variables that are part of my recipe. In this case, it shows two variables, one for the compartment ID, where this needs to be deployed, and the second is for the base image of my web server. I want to deploy this into a new compartment that I have already created, so let's paste the compartment ID for this new duplicate compartment in the compartment field, and we leave the web server source ID as is. Now we can finish creating the stack. If we go to the Terraform Actions menu and click Apply, the Resource Manager will try to execute the Terraform recipes. During this process, you will see a log file. And in our case, we instantly see that there's actually something wrong with our recipe. It's saying you need to provide an admin password for the autonomous database. When the discovery was happening, it could of course not read out the password used by my autonomous database. So we need to change that into a Terraform variable. When we look at the created files, you will see that there's a database.tf file. In here you will find the details for creating the autonomous database. In the top of the file you see that there's already a placeholder that is remarked out for the database password. So let's unremark this and turn it into a Terraform variable. We do this by specifying it like this. We now have a new Terraform variable called db_password. Now an autonomous database needs to have a unique name in your tenancy. So we also need to make the database name into a variable. Let's call this the database or db_name and use this for the database name and the display value. We also need to add these variables to the vars.tf file. This is a file used to present the list of all variables that can be used in this recipe. If we now rezip the file and update it in the Terraform stack, using the Upload New button, you will see that it now asks for our additional database password and our database name variables. Let's save the changes and retry the apply action. You will see one more error popping up. It's complaining about an invalid parameter for the web server. So let us fix that. I will modify the core.tf file. This is where you'll find all the compute resources, and remove this line in the script it is complaining about. Let's again zip this up, upload it into our stack. The variables should stay the same. And now we can run apply command again and check the log file. As you can see, the web server is now also being provisioned. If we go back to the compartment explorer and open the duplicate compartment, you will now see I have a copy of this environment. The great thing about Terraform is that it not only can provision environments, you can also automatically destroy anything that you have created with your recipes. So when we go back to the stack and resource manager, we can run the Terraform action called destroy. This will now reverse the recipe and delete all the resources that were created. As you can see, Terraform allows you in a very easy way to provision new environments based on recipes and also delete them. If you do not know how to spell out each element of your recipe, just create one by hand and run the discovery module, and then modify your created recipes to your likings, including making components dynamic using this concept of Terraform variables. Thank you for watching. For more tips, tricks and scripts, check out my Oracle Cloud blog on www.oc-blog.com. It also features a list of aggregated news from around the world on OCI topics from various official Oracle blogs and community bloggers. This list is also available in the OCI Manager iPhone app I have written that you can find on the Apple App Store. And please do not forget to like and subscribe. Bye for now.